Now this is confusing people, so let's look here. Let's put it this way, because you're used to fundamental triangles, right? Like I say, sketch a fundamental triangle that starts at the vertex, right? With a run of 1, okay? And ending up on the parabola. Okay?
Does it always have to have a run of 1?
You just do exactly what it says.
No, like if we're doing another triangle, say the points were like 4, will it always, like, do we always go 1 over? So
I'm sorry, I didn't catch all that.
Or like say we had different numbers, like, okay, all those 2's were 4s, would we always want to have a run of 1?
Well, on the document that we're working from, this thing that I handed out,
So it doesn't necessarily always have to have a run of 1?
yeah, we're doing this one, but yes, if you have a different labeling of the axes, you're still going to do this.
So you're always
It's
going to
just
have
that if this was 4, then 1 would be smaller, right?
Stretched from 1.
Okay. So you always have a run of 1?
Yeah, if you do a run of 1, then the rise will be your vertical stretch A.
Okay.
Okay?
Okay.
Sketch from one triangle starting at vertex from 1 and then up on parabola.
So if you do that triangle, what's your rise? Some people are saying a half, some people are saying less than a half.
I say more than a half.
And some people are saying more than a half, yeah, well, okay, yeah.
Just very slightly.
Okay, I haven't drawn it on the thing, I don't know, it
So
looks,
this is the technique you use to find the stretch, basically.
yeah, this will give you the stretch. We'll talk about why, but let's, right now, just say this is how you get the vertical stretch. Okay?
Okay.
There's a simple reason for it, but let's not complicate things with the reason. Let's just have a rule that if you sketch this fundamental triangle, where this is 1, then this is going to be your vertical stretch. Okay? It's going to be your value of A in the standard form. So what do you think A is? How many do you think it's 1/2? How many think it's 0.4? How many think it's 0.3? How many think it's 0.6?
No, not 6.
How many think it's 0.2? How many think it's less than 0.2?
It don't really matter.
How many think it's more than 0.6?
It don't really matter.
Yeah, you're doing an estimate.
Yeah.
It kind of matters, but you want to make your estimate as accurate as you can, but you don't expect to be totally accurate, right? But this gives you a ballpark that allows you to then write an equation, right? Okay, so what's the equation of this parabola?
Y equals 0.6 x squared.
Well, now, you see that the vertex is what?
Hypothetically speaking, 0.6.
0.
3/2.
1.
I would say it's 0, -1. No, actually,
I'd
it
say
looks
it's
a
like
little lower than
1.1.
-1, doesn't it?
Yeah, I put like negative
Okay.
1.1.
So you can estimate that, maybe -1.2. Okay? For that particular picture. And A equals then, let's just take 0.4, because that's kind of in the middle of all your estimates, okay? Now these are estimates. But according to those estimates, standard form is approximately 0.4 times x minus 0 squared minus 1.2. So our
0.4
conclusion,
is the rise.
with a question mark,
30.
Now, 1.2 is
again,
Yeah.
an estimate, right?